Okay, I hope all this tidying is really sparking joy with you, just like Marie Kondo would want. So let's keep it going. This is where the real tidying comes into play, and I tell you what, this sparks joy for me for sure. But before we jump into the math, you might be wondering why I have all this fruit on the screen. Well, we're going to look at this with a concrete example before we focus on the numbers and variables and all that, okay? So we're going to group the fruits that are the same. Very simple, okay? And so just take a second, kind of identify what you see, right? And I'm gonna start with the oranges, right? These two are already next to each other, so I'm going to group those together. Okay, I got my oranges, grouping those all together into an orange pile. Don't want to leave any behind. So I'm getting all my oranges grouped together, and I know this isn't in your notes, but kind of think about where we might be going with this next, okay? So now I'm going to group these grapes together because they're kind of in my orange pile, and I want to get them in their own pile. So I'm grouping my grapes together, getting all of them, don't want to leave any behind. Getting them all in the same pile, all nice and tidy. Okay, so there's my, oops, I missed a grape. There it is. All my grapes are in a pile. All my oranges are in a pile. Let's do the pineapples now. Oh, I love pineapples. Let's get them all together. Not too many of them. And then let's get these apples together. So I had, now that might have been hard for you to notice, but I ended up having 4 different groups. I had oranges, grapes, apples, pineapples. And so now they're all grouped together. Nice and neat. Look how organized that is. How nice. Tidying it up. That really sparks joy for me. So you might be asking me, why are we organizing fruit? Well, let's think about this with our terms, right? We talked about terms back when we were looking at parts of an expression, and so terms are separated by addition and subtraction signs. So now we're going to talk about like terms. So like terms are terms that have the same variable or variables, there might be more than one, raised to the same power. Okay, you'll see what I mean in a second. And so all constants are also terms. So notice constants, remember, those are the numbers that stand by themselves. They do not have a variable with them, but those are also terms. Remember, we talked about that before. Like terms can be added or subtracted. Right? So that's kind of what we're looking to separate them. So we should never be multiplying or dividing terms. They're always added or subtracted. So now we're going to talk about combining like terms. So before we combine them, we're just going to take that same idea I just did with the fruit and do this now with your numbers and variables. So with these mathematical terms, instead of using the fruit, right? Because if you think back, we didn't put the grapes and oranges together, right? Because the grapes and oranges don't belong together if we're grouping by fruit, right? And even though the oranges and apples are both very circular, they're round, they look kind of similar, they are not the same kind of fruit, so we did not put them together, right? So we're going to do that exact same idea with our mathematical terms, okay? And so I'm going to be able to pull these and group them. What you're going to do is pick a shape depending on what term we're looking at. So I'm going to start with M. Okay, now you might say, well, hey, we've got M and X. Those are both just letters. Well, but you have to think, right? Letters, these are really variables, and variables are in place of an unknown number. So we don't know what M is, we don't know what X is, but because they're not the same variable, they are representing different numbers, so we cannot put them together. And you might be thinking, well, this is M to the third. But remember, if we go back to our like terms, it has to be the same variable raised to the same power. Well, M to the third is not the same as just M, right? This would be like M to the first. So those can't go in the same one. Now what I could do is anything that is showing more than one M, right? Because remember our coefficient for this would be 1M. So if I look over here, I've got 3M. Well, those would work, right? Because if I put those together, for example, I'd have 1M and 3M together, I'd have 4M. So those are the same. So you can go ahead and put whatever shape you choose for the M's. You can put that around M and 3M. Let's see if we've got any others. If I scroll down, yep, we have a 2M. So I'm going to drag that over here. Okay, and these all make a group. I think that was all of them. If I missed any, we'll go them in a second. All right, so this is a group, and so you should have the same symbol around those 3 M's, okay? The M, the 2M, and the 3M. All right, let's look at the 5X, okay? So like we said, that's not the same as the M's over here. We have 5X, and so I'm going to take my X, right, because it's 1X. Well, those are the same. Now remember, we can't include the x squared because that is to a different power, so we can't include that. But do we see any other x's? Oh, there's a 4x over here. So make sure you pick a different shape for these than you did for the m. So you could do a circle, a triangle, a box, or if you have different colors, you want to pause and get some different colors to use. I don't care, just make sure you can understand which terms go with which group. All right, are there any other x's? Nope, I'm not seeing any, so that's the group for now, okay? All right, I'm noticing some of these, like, for example, there's 4 just by itself, so no variable, okay? And I see 0 is also like that. So I'm going to put those in a group. Remember, those are like constants, and so those would go together because they have no variable raised to no power. So I've got 4, 0, I've got 9, I've got 7. So those all go together, okay? So make sure you choose a different symbol for that to identify those. I'm going to do my x squared. So I've got 5x squared here. I'm going to join that with the x squared over here, right? Because altogether that'd be 6x squared. Do I see any other x squareds? Nope, I think just those two. All right, let's get to the m to the third. So 2m to the third. I have an m to the third. Do I have any other m's to the third? Oh, yep, there's 15m to the third. Okay, so make sure you have another symbol that represents those. Okay, oh, I see this one. I've got a, b. Oh, interesting. Those are two variables, right? A and b, and they're both raised just to the first power because there's one a, right, and then just for no power here, so just b to the first power. So I'm going to add my 2ab to that, right? They have the same variable raised to the same power. I'm going to add my 12ab over here as well. So I think I got all the ABs. All right, I see all these U's. I'm going to get my 2U and my U. I'm going to bring it down just a little bit so it's away from the ABs. And my 3U. And if you need to pause the video, feel free. I want you to make sure you can catch up because I know I'm dragging mine, but you should be able to put the same symbol around them, right? You could even use like a cloud or a heart or star them. Just as long as it's a different symbol and you're using that symbol for all the terms that would be in that group, then you're good to go. Okay, so I got my U's. Oh, here's one more, 7U. All right, my last group are these y squared. So I got y squared and 4y squared. All right, so if you can see, I've got my different groups here, right? I've got the constants, they're just the numbers with no variables. I got my m's, I got my x's, my m's to the thirds, my x squareds, my y squareds, my ab's, and my u's, okay? So I had 1, 2, 3, 4, 5, 6, 7, 8 different groups, okay? So that's the idea when we're combining like terms, right? We're looking for the same variable raised to the same power, or maybe no variable at all. So let's try this with a couple examples. Again, if you need to pause and go back, feel free. All right, so this is where this really matters. Now that you understand how to tidy up these expressions by combining like terms and what you're looking for, let's go ahead and apply it. So we're going to simplify the expressions by combining like terms. So let's look at this first one. We have a plus 2a minus 2b. So all I'm looking for is what like terms are there. And when I see I have an a and a 2a, I know those are the same variable raised to the same power. And if it helps you, you could underline them if you want. Where am I? There we go. To kind of draw your attention in. And these happen to be a little bit easy because they're right next to each other. So I know I'm taking a, which remember that's like saying 1a. And if it helps you to write in the 1, feel free. But this is saying 1a plus 2a to get 3a. Now 2b doesn't have anything with it, and so we're just going to bring it along. But if I look in front, it has a subtraction sign, so that means I'm going to have 3a minus 2b, right? See how I joined those a's together? I kind of just tidied them up and grouped them together to get 3a, and then I just didn't forget about my minus 2b. I just brought it along with me. So this expression is equivalent to this expression, and this is as simple as you could get. You can't go any further unless you knew what a and b represented. Okay? Let's try another one. So this one's a little bit longer, but if I kind of zero in, I've got n squareds, so I've got 9 of them here and 4 of them here, so I could underline those if that helps me kind of focus in on those. But then I also have a 36 that's just by itself, no variable, but I also have a 4 by itself with no variable, so those also will go together. So let's just work our way left to right, right? That way we don't get anything mixed up. So I have 9n squared. And when I look at this 4n squared, I need to look in front of it to see, well, what am I doing? Am I adding the 4n squared or am I subtracting them? And in this case, I'm subtracting them, so we end up with 5n squared. The n squared just stays the same. There's nothing going on there. We just focus on the coefficient part. And so I have 9 of the n squareds, take away 4 of the n squareds to left with 5n squared. And then I'm just going to put an addition sign. And then I do the same thing with my term. I have 36. Look at the plus 4. I'm not using the subtraction symbol anymore because I already used that with the n squareds. I'm looking at the just number, right? So I want plus 4. So 36 plus 4 to get 40. So there's my 5n squared. I use that addition sign from here because I just went left to right. And then I get 40 from the 36 plus 4. Okay, and that's as small as I can get, simple as I can get. Okay, let's look at one more. This has a lot going on. Let's pick it apart. So I look first, I've got a 7x. Are there any other x's? Yep, there's one right, oh, where'd my line go? There it is. 7x, that's the same as 3x, right? And if I'm looking at that, I got 7x minus 3x to get 4x, okay? Then I'm going to be adding, and I've got 6y, and then there's another y, except it's 4, so I'm doing, the lines aren't showing up, 6y minus 4y to get 2y. And then I don't have any other y squared, so I'm just going to bring that plus 2y squared with me. So we end up with 4x from the 7x minus 3x plus, right, I just bring this addition sign with me, 6y minus 4y, so I get 2y. And then we already took care of this x up here, so we just keep going with plus 2y squared. And you can kind of see how I just brought that with me. And that's as small as we can get. We cannot put the y and the y squared together because it's not the same. It is the same variable, but it's not to the same power, okay? So you have some practice to go try. If you need to refer back to the video, feel free, or back to your notes, go ahead. And you need to get a peer signature after you've checked with the answer key, okay? And then you can move on to a little bit more complex combining like terms. Good luck tidying these expressions.